Welcome to Nova English. Ready to level up your English? Here we learn through stories, slow, clear, and fun. Listen, relax, and enjoy the journey. Yesterday, I walked into the kitchen, stood there for 10 seconds, and then muttered, "Why did I even come in here?" Sound familiar? The same thing probably happened to you last week, didn't it? We all do it. We treat these little mental blanks, these moments of total forgetfulness, like annoying glitches in our otherwise brilliant brains. But what if I told you to picture something truly wild tonight? Something that completely flips that idea on its head. Forgetting isn't a bug. It's not some error in your system. Oh no, your brain actually pressed the delete button on purpose. It's an active, intentional process designed to make you smarter. Right now, as you're watching this, deep inside your skull, millions of neurons are working overtime, weighing memories. They're scanning them with the precision of TSA agents at airport security, deciding, keep, toss, or maybe even explode with a big, flashing red light. And here's the craziest part, the thing that always blows my mind. The stuff that disappears isn't random. It's not just whatever happens to fall out of your head. Your brain is running a secret, high-stakes auction for every single piece of information it encounters. Every sight, every smell, every homework answer, every heartbreak, every single item on your grocery list, all of it bids for incredibly limited shelf space in your mind. Tonight, we're going to sneak into that auction. We're going to eavesdrop on the bouncers, peek behind the velvet rope, and learn why that most embarrassing moment from middle school somehow keeps outbidding your ATM pin, or even what you had for breakfast yesterday. If you've ever wondered why you can remember the quadratic formula from high school calculus, but you can still vividly taste your grandma Yush's homemade soup, then you absolutely need to stay put. By the end of this, you'll not only know exactly how your brain picks the winners in this memory game, but you might even forgive yourself for constantly losing your car keys. Crucially, you'll understand that this isn't a flaw, but a feature designed for your survival and sanity. Section 1. Why perfect recall would break you. Let us start with a number that genuinely blows my mind every time I hear it. Every single waking second, your senses are soaking in an astounding 11 million bits of information. Think about that for a moment. Your eyes alone, these incredible biological cameras, deliver roughly 10 megapixels of data to your brain every second. That's way more than even your favorite high-definition video game. Now, imagine if you actually kept even 1% of that torrential downpour of data. Your skull wouldn't just feel full, it would feel like a hoarder's closet, overflowing with useless junk by lunchtime. You'd be completely paralyzed by the sheer volume of sensory input. Evolution, in its infinite wisdom, didn't hand us a bigger hard drive that could store absolutely everything. Instead, it did something far more brilliant. It hired a ruthless, highly efficient editor. Neuroscientists have a name for this incredible process. They call it adaptive forgetting. And crucially, without this editor, without this constant pruning and prioritizing, life as we know it would simply become impossible. Consider the famous and, frankly, quite tragic case of a man known only by his initials, SV. After suffering a minor head injury, SV lost the ability to forget. Sounds like a superpower, right? The ultimate memory hack? Well, the reality was anything but. Within months, SV was utterly paralyzed by detail. He could recite every single phone number he'd ever seen, every license plate, every conversation, every mundane detail of every single day. But here's the kicker. Something as simple as choosing a sandwich took him hours. Why? Because he remembered every single ingredient of every sandwich he'd eaten since 1997. He couldn't make a decision because he was drowning in a sea of irrelevant information. Doctors eventually labeled his condition pathological hypermnesia, and it completely wrecked his job, his relationships, and even his ability to sleep. His story isn't a tale of triumph. It lands like a horror movie trailer, a stark warning. Perfect recall isn't a gift, it's cognitive gridlock. Your brain's ultimate mission isn't to archive every single second of your life. Its true purpose is to make you swift, decisive, and ultimately sane. Forgetting, then, isn't a flaw. It's the essential price of clarity. It's what allows you to focus on what matters, to learn, and to adapt. Section 2. Meet the Bouncers, Hippocampus and Friends. So, if our brain is this exclusive nightclub of information, who exactly is running the show? Who are these bouncers deciding what gets in and what gets the boot? First up, we have the star player, the hippocampus. These are two fascinating little seahorse-shaped curls parked deep behind your ears. And here's a crucial distinction: it and not. Your long-term memory vault itself. Think of the hippocampus more like the ultimate bouncer, standing firmly at the velvet rope of the VIP section. When a new experience, a new piece of information, or a new sensation rolls up to the club, the hippocampus immediately starts checking its guest list. What's on that list? It's looking for things like emotional salience. How much did this moment matter? Was it novel? Something completely new and unexpected? Was there repetition? Did you encounter it multiple times? And was there a reward associated with it, something that made your brain say, "Hey, this is good"? If a memory fails this rigorous test, it gets the polite but firm, "Sorry, we're full tonight," and it simply fades away. But if it passes, if it meets the criteria, the hippocampus sends the all-clear code to the cortex, where wider networks begin to knit that story into the rich tapestry of your personal timeline, turning it into a lasting memory. But this bouncer doesn't work alone, not in this bustling brain club. Next up is the prefrontal cortex, often abbreviated as the PFC. This powerful region, located right behind your forehead, is like the club manager. It can actually override the hippocampus, especially when a memory feels particularly dangerous, gross, or just plain unwelcome. Imagine you're scrolling online and accidentally stumble upon a truly violent or disturbing scene. Your PFC, acting like a protective filter, slams the hippocampus with inhibitory signals. It's basically muting the retrieval, saying, "Nope, not today. We're not letting that in fully." So you can keep scrolling without vomiting all over your keyboard. It's a crucial mechanism for protecting your mental well-being. Meanwhile, while all this VIP selection is happening, the anterior thalamus is acting like the most efficient courier you can imagine. This brain region is constantly shuttling those chosen memories from their short-term lockers, the initial holding pens, to their long-term shelves in the cortex. And when does this courier do its best work? While you sleep. Here's a fun fact that always surprises people. During deep sleep, this memory courier is so incredibly busy, so active, that your thalamus consumes almost as much energy as it does when you wide awake and intensely solving complex crossword puzzles. It's not just resting. It's working hard to consolidate your day's experiences. And finally, we have another critical player, the amygdala. This almond-shaped region is the emotional powerhouse of the brain. If an event carries a strong emotional charge, be it fear, lust, triumph, or profound joy, the amygdala sprinkles what I like to call emotional adrenaline all over that memory. This immediately pushes it to VIP status, practically guaranteeing it a spot in your long-term archives. That's precisely why you can vividly remember your first kiss the exact moment you heard big news or a truly terrifying experience. But you probably have absolutely no recollection of what you had for breakfast on March 3rd of last year. Emotion is a supercharger for memory. Section 3. The molecular shredder, how memories physically vanish. Okay, so we've talked about the bouncers and the guest list. But what actually happens on a microscopic level? How do those memories that do make the cut physically get stored? And then how do they physically vanish? When a memory is deemed important enough to keep, it's stored in specialized groups of neurons called engram cells. These aren't just any old brain cells. These cells literally remodel their own DNA. Scientists call this process chromatin loosening. Think of chromatin as the tightly wound spool that holds your DNA. For a memory to be encoded and accessible, this spool needs to loosen up, allowing specific genes, the ones needed to hold and retrieve that memory, to switch on. It's like unlocking a specific file cabinet in the vast library of your brain. But here's the truly cool part: the mind-bending bit. The very same molecular mechanism that allows memories to form also works in reverse when your brain decides it's time to dump data. It's not just passive decay. It's an active, deliberate erasure. And guess what one of the key players in this molecular shredding is? Dopamine. Yes, that famous reward chemical, the one that makes you feel good, actually doubles as a demolition notice for memories. Studies have shown this clearly. If you give rats bursts of dopamine after, they've learned a maze. They forget the route significantly faster. Why? Because the dopamine flags that specific engram, that memory trace, for what scientists call synaptic removal. Essentially, the hippocampus starts yanking out AMPA receptors. These are tiny, crucial docking stations on the surface of neurons that allow them to talk to each other. They're like the ports on a switchboard. Without those docks, without those communication points, the synapse quiets down, the signal weakens, and the memory simply fades away. It's an elegant, targeted deletion. But there's another fascinating route to forgetting, and it involves brand new neurons. Your hippocampus, remarkably, mints fresh cells every single day, a process called adult neurogenesis. These newcomers aren't shy. They muscle their way into existing neural circuits like rowdy freshmen grabbing the best seats in a crowded lecture hall. And to make room for these eager new students, old, less used connections often snap apart. It's like a constant renovation project, ensuring your brain remains flexible and adaptable. Researchers at the University of Toronto demonstrated this beautifully. They boosted the rate of neurogenesis in mice and then observed what happened to their memories. Entire fear memories, previously established, literally evaporated. The mice completely forgot they'd ever been shocked in a certain cage. So the next time you wake up feeling a little fuzzy on yesterday's errands, or you can't quite recall that obscure fact you learned last week, picture those newborn neurons deep in your hippocampus doing their renovation work, crowbars and blueprints in hand making space for new, more relevant experiences. It's not a malfunction. It's an upgrade. Section 4. Intentional Amnesia, the Art of Motivated Forgetting. Sometimes we don't just wait for our brain's natural biological shredder to do its work. Sometimes we actively, consciously shove memories out ourselves. Psychologists have a term for this powerful ability. They call it motivated forgetting. It's a truly fascinating aspect of our mental resilience. It's why, for instance, a veteran who once had a terrifying experience associated with the smell of diesel fuel might, over time, genuinely struggle to recall that specific scent, even though it used to trigger debilitating panic attacks. Their brain, with conscious effort, has learned to suppress it. In controlled lab settings, researchers can actually observe this happening. Subjects are taught pairs of words, say, ocean wave and fruit apple. Then they're given a specific instruction: don't think about apple. What do fMRI scans show during this task? They reveal a clear active engagement of the prefrontal cortex, the club manager we talked about earlier, revving up its activity, and at the exact same time, hippocampal activity dips significantly. It's like a mental dimmer switch, with the PFC actively tamping down the hippocampus's ability to retrieve that specific memory. With enough deliberate practice, that unwanted word, apple, floats farther and farther from conscious awareness. It doesn't disappear entirely, but its accessibility is greatly reduced. This isn't just a cool lab trick. This ability to intentionally suppress memories is incredibly therapeutic. Patients suffering from post-traumatic stress disorder, or PTSD, often train on these think-no-think tasks. And the results are genuinely encouraging. After just a month of consistent practice, their intrusive flashbacks, those terrifying, unwanted replays of traumatic events, can drop by a remarkable 30%. It's a testament to the brain's incredible capacity for self-regulation and healing. But, and this is crucially important, suppression has a dark twin, a more insidious counterpart: repression. While suppression is a conscious, deliberate effort to push a memory away, repression is often an unconscious process. If you repeatedly bury painful, unprocessed stuff deep down without ever truly confronting it, that memory doesn't just vanish. It can morph. It can manifest in unexpected and debilitating ways: chronic headaches, recurring nightmares, or random, inexplicable surges of anxiety. It's your brain's way of saying, "Hey, this unresolved issue is still here, and it needs attention." The bottom line here is profound. Your brain will certainly let you delete or at least suppress unwanted memories, but it often keeps a kind of shadow copy, tucked away in a mental recycle bin. And sometimes, unfortunately, that bin can leak, causing distress. Section 5. Incidental Force: How Remembering One Thing Erases Another. Now let's talk about another fascinating and often frustrating way your brain decides what to forget, one that happens almost accidentally. Have you ever crammed intensely for a Spanish exam, only to then realize that your French vocabulary, which you knew perfectly last semester, has suddenly turned into mush? If so, welcome to the world of retrieval-induced forgetting. This isn't your brain being petty or actively trying to sabotage you. It's actually being incredibly efficient. Think of it like this. When you yank one specific file from your mental cabinet, say the Spanish word for hello, your brain, in its effort to retrieve only that file quickly and cleanly, temporarily suppresses or weakens all the competing files, like the French word for hello. It's a form of mental tidying, clearing out the clutter so the right answer can shine. Cognitive scientists have demonstrated this with clever experiments. Imagine being asked trivia questions. If you repeatedly practice retrieving the correct answer to "What's the capital of Australia?" which is Canberra, by the way, your brain actively suppresses the incorrect but strong competitor: Sydney. Why? Because Sydney keeps elbowing its way into your conscious thought, trying to be the answer. Over time, that suppression makes Sydney harder to recall, even though it's Australia's biggest and most famous city. The brain is saying, "No, this isn't the right answer for this context, so let's make it harder to access when we re-looking for the capital." This subtle but powerful mechanism shows up everywhere in our lives. Musicians who intensely rehearse a challenging piece A on the piano might find themselves stumbling on piece B, which they learned perfectly last year. Medical students who spend weeks drilling the intricate details of endocrinology might suddenly bomb a simple anatomy question that they once knew cold. The very act of focusing on and retrieving one set of information temporarily inhibits the retrieval of related, but currently less relevant, information. So, what's the fix for this accidental erasure? It's a technique beloved by students and lifelong learners: spaced repetition. By cycling through topics days or even weeks apart, rather than cramming them all at once, you allow that inhibitory dust to settle. You give your brain a chance to reactivate those temporarily suppressed details, ensuring that the forgotten information can climb back into accessibility. It's about giving your brain time to reset its mental filing system. Section 6. The Keepers: Memories Your Brain Never Tosses. If forgetting is indeed the default setting, the brain's preferred mode of operation, then what on earth earns a memory true immortality? What kind of information gets past all the bouncers, bypasses the shredder, and is laminated for life? Well, there are 3 big tags, 3 powerful signals that tell your brain, hold on to this one. These are novelty, emotion, and story. 1. Novelty. When something is new, unexpected, or unusual, it immediately lights up your brain's dopamine system. That surge of dopamine acts like a spotlight, highlighting the experience and telling your brain, "Pay attention. This is different. This might be important for survival or learning." It's why you remember the first time you tried a really exotic food, but not the 10th bowl of cereal. 2. Emotion. As we touched on earlier, emotion is a memory supercharger. When an experience carries a strong emotional charge, be it joy, fear, surprise, or anger, it recruits the amygdala. The amygdala essentially sprinkles that emotional adrenaline on the memory, etching it deeper into your neural networks. 3. Story. Our brains are hardwired for narrative. We don't just remember isolated facts, we remember stories. When you stitch facts into a coherent narrative, your brain finds it much easier to recall. It provides context, meaning, and a natural flow. Combine these three powerful tags: novelty, emotion, and story. And what do you get? You get what scientists call super memories. This is precisely why people old enough for Social Security can often describe in vivid detail exactly where they were and what they were doing when they heard about pivotal historical events like when Kennedy was shot or when the Twin Towers fell. These are known as flashbulb memories. While they might not be perfectly accurate in every single detail, they are incredibly resistant to the shredder of time. Repetition also plays a significant role, especially when it's spaced out over years. This is why you still effortlessly know the alphabet, or can sing the lyrics to a childhood song without even thinking. The consistent, spaced-out exposure solidifies those neural pathways. Finally, and perhaps most powerfully, memories that are intimately tied to your identity get practically laminated. Your name, your hometown, your favorite song from when you were 15, who your closest friends were, your core beliefs. These aren't just facts. They define you. Your brain flags these as "do not delete" information because they are fundamental to your sense of self. Have you ever noticed how you can recall the exact brand of jeans your crush wore in 8th grade, the specific shade of blue, but you completely forgot the Wi-Fi password you just reset yesterday? As a perfect illustration, identity beats utility every single time when it comes to memory retention. Your brain prioritizes what makes you, you. Section 7. Tech that hacks forgetting. Implants, lasers, future stuff. Now, let's talk about something that sounds straight out of a sci-fi movie, but is actually bleeding into reality right now. Technology that can literally hack our ability to remember and forget. It's both exhilarating and, frankly, a little terrifying. Consider the groundbreaking work happening at places like Wake Forest Baptist Medical Center. Surgeons there have been able to slip tiny electrodes directly into the brains of epilepsy patients. They then built an incredibly sophisticated algorithm that can actually predict when a patient's memory is about to fail. When this chip senses trouble, when it detects those telltale neural patterns of an impending memory lapse, it delivers a precise zap of microvolts to the hippocampus. The result? A remarkable boost in recall by up to 35%. Imagine that. This isn't just theory, it's happening. And it's so promising that DARPA, the research arm of the U.S. military, is already funding a portable version of this technology for soldiers, hoping to enhance their cognitive function and memory in high-stress situations. But it gets even wilder. Elsewhere, scientists called optogeneticists are working with genetically modified mice. They can literally shoot lasers into specific neurons in these mice's brains, and in doing so, switch memories off, then switch them back on again, almost like unplugging and replugging a lamp. The immediate noble goal here is to treat debilitating conditions like PTSD without the need for pills, offering a targeted way to dampen or even erase traumatic associative memories. However, as you might imagine, ethicists are already sweating. And for good reason. The implications are enormous. If we develop the power to selectively erase a war veteran's trauma, which sounds incredibly compassionate, What are the potential downsides? Could an abuser, for example, somehow erase a victim's testimony? Could governments manipulate historical records by erasing collective memories? These aren't just hypothetical questions. They are urgent ethical dilemmas we need to grapple with. Now. One proposal gaining traction is to make any memory edits reversible, much like how computer administrators keep backups of important data. We're certainly not there yet, but the blueprint, the scientific possibility, absolutely exists. Imagine, for a moment, a slider on your phone, not for screen brightness, but for your memories. Slide left to forget a painful experience. Slide right to enhance your recall for an upcoming exam. Neuroethicists are rightly arguing that this kind of powerful technology needs a significant waiting period, much like regulations around gun purchases, to prevent people from impulsively nuking pain that, crucially, might actually help them learn, grow, and develop empathy. The power to edit our past is a power that demands immense caution and profound consideration. If you're finding this deep dive into your brain's secrets as fascinating as I am, then seriously, hit that subscribe button right now. Your brain will thank you for it. Well, if it remembers, that is. I post weekly videos just like this, unpacking the strangest, most incredible neuroscience concepts in plain English, making them accessible and fun. And don't forget to hit that little bell icon so YouTube's algorithm, another ruthless editor we have to contend with, doesn't forget to notify you every time a new video drops. Join our community and let's keep exploring the wonders of the mind together. Section 8. Everyday Hacks: How to Protect the Memories You Want. Enough with the mind-bending future talk for a moment. Let us bring it back to earth and focus on what we can do today to protect and enhance the memories we want to keep. Because, crucially, you have more control than you think. 1. Prioritize sleep seriously. This is the big one. We talked about the anterior thalamus acting as a courier, right? Well, during slow-wave sleep, which is your deepest, most restorative sleep stage, your anterior thalamus doesn't just shuttle memories, it actively replays them. And get this, it replays them at an astonishing 20 times their normal speed. This rapid-fire replay is how your brain locks those fragile, newly formed memories into long-term storage. It's literally consolidating the day's learning. So, when you pull an all-nighter, thinking you're gaining an edge, you're actually sabotaging this vital process. Just one all-nighter can slice your memory recall by a staggering 40%. It's like hitting delete on a third of what you just tried to learn. So, treat sleep not as a luxury, but as a non-negotiable memory-building activity. 2. Embrace interleaving. Most of us were taught to study by blocking, drilling one skill or topic for an hour straight, but your brain actually thrives on variety. Instead of spending an entire hour on just algebra problems, try interleaving. Mix similar but distinct topics. Spend 20 minutes on algebra, then 20 on geometry, then 20 on statistics. Your brain is forced to constantly adapt, to recognize the unique patterns of each topic. This makes each piece of information feel more novel and distinctive, helping your brain tag it as unique and therefore worth keeping. It's like making sure each item on the guest list stands out. 3. Add emotion and story. We know emotion and story are memory superchargers. So, don't just passively read facts. Actively attach a joke, a ridiculous rhyme, a vivid, even outlandish image, or a personal story to boring information. Remembering a dry date like 1853 is incredibly hard for most people. But remembering, in 1853, Commodore Perry sailed into Japan like a rock star, a real Kanye concert of a diplomatic mission. Now that sticks. Make it funny, make it dramatic, make it personal. Your amygdala will thank you. 4. Practice pulling, not just cramming. This is a game changer for learning. Rereading your notes might feel productive, but it's often a passive activity. Instead, Practice pulling information out of your brain, actively retrieving it. Flashcards with immediate feedback are far superior to just rereading a textbook. Why? Because active retrieval mimics the real-world survival decisions your brain constantly makes. Is this information useful enough for me to access quickly? The effort involved in pulling it out strengthens the neural pathways, making the memory more robust. It's like giving your bouncer a workout. 5. Manage your stress. Chronic stress is a memory killer. When you're constantly stressed, your body floods with cortisol, the stress hormone. And here's the problem. Chronic cortisol literally shrinks hippocampal neurons. Remember the hippocampus, our bouncer? When those neurons shrink, your bouncer becomes too tired, too overwhelmed to effectively stamp the right tickets and decide which memories get in. It impairs its ability to encode and consolidate new information. Even just 5 minutes of simple box breathing, inhaling for 4, holding for 4, exhaling for 4, holding for 4, can cut your cortisol levels in half and literally save your precious memories from being thrown into shredder mode. Protect your bouncer. Section 9. When forgetting goes wrong. Disease versus normal slips. So, how do you know if your occasional blanking, those moments of, "Why did I come in here?" are just normal, healthy forgetting, or something more concerning? This is a crucial question that many of us grapple with, especially as we get older. Let's be clear. If you forget where you parked your car at the mall, or you can't quite recall the name of an acquaintance you met once, that's completely routine. Your hippocampus, that diligent bouncer, likely downgraded yesterday's parking spot because, let's be honest, it probably looked just like every other parking lot you've ever been in. There was no novelty, no strong emotion, no compelling story. It was efficiently pruned away. That's your healthy brain at work. But, and this is the critical distinction, if you forget that you own a car, or you can't recognize your own family members, then that's a clear signal to see a doctor immediately. True, pathological forgetting is a different beast entirely. Alzheimer's disease, for example, often starts its insidious work in the entorhinal cortex, a region located right next door to the hippocampus. It often begins by erasing a person's sense of time and place, long before it impacts other types of memory. It's also important to understand that not all memory issues are directly about memory storage. Conditions like severe depression can mimic dementia by smothering motivation and attention, making it seem like memories are gone when they were simply inaccessible due to a lack of engagement. It's not a problem with the storage itself, but with the retrieval mechanism being overwhelmed by other factors. Similarly, easily treatable physical conditions like thyroid issues, vitamin B12 shortages, or even urinary tract infections, especially in seniors, can create what we call fake forgetfulness. These are physiological issues impacting overall brain function, not necessarily memory degradation itself. Here is a good rule of thumb to help you distinguish. Memories you can eventually recall with a hint, a prompt, or a bit of context were never truly lost. They were just poorly filed, tucked away in a corner of your mental cabinet that was hard to access. The information is still there, but memories that completely vanish, despite strong hints or significant effort, and those that you simply cannot retrieve, may signal something more serious, potentially damage to the brain's memory systems. Crucially, pay attention to the people around you. If friends or family members start noticing significant changes in your memory or cognitive function before you do, that is a definite red flag and absolutely worth a visit to a neurologist. They have the tools and expertise to properly diagnose what's happening. For most people under the age of 50, however, those everyday slips, those moments of forgetting a name or where you put your keys, are overwhelmingly a sign that your system is healthy, efficient, and actively pruning away the unnecessary twigs so that new, more important branches of knowledge and experience can grow. It's a sign of a dynamic, adaptable brain. Conclusion. Tonight, we didn't just scratch the surface. We cracked open the skull, metaphorically speaking, and took a fascinating look inside, watching your personal editor, your brain's ruthless but brilliant curator, at work. What we've learned is truly transformative. Forgetting isn't the enemy. It's not a flaw, a bug, or a sign of weakness. Oh no. It is your silent, indispensable partner, the unsung hero that keeps you sane, keeps you swift, and yes, even keeps you creative. Every single lost key, every forgotten name, every fleeting thought that slipped away, these aren't failures. They are the small, necessary price we pay for a brain that intelligently prioritizes profound meaning over mundane minutiae. So, the next time you blank on a name in a conversation, or you walk into a room and forget why you're there, try not to stress. Instead, smile. You just caught your brain's bouncer doing overtime, working hard to keep your mental space clear for what truly matters. If there's something you genuinely want to keep forever, something precious you don't want the shredder to touch, remember the hacks we discussed. Wrap it in a compelling story, infuse it with strong emotion, revisit it using spaced repetition, and then, crucially, sleep on it. Let your thalamus do its nightly consolidation magic. And before you ever find yourself envying those rare individuals who seem to possess a photographic memory, take a moment to remember poor SV, paralyzed by the overwhelming weight of every single detail. A perfect, unedited past, filled with every single data point, is utterly useless without a functional, usable present. So, go ahead, thank your hippocampus for being such a discerning bouncer. High-five your prefrontal cortex for its incredible executive control. And maybe, just maybe, apologize to all those grocery lists and unimportant facts that were doomed to disappear. They were sacrificed for your cognitive clarity. If this video has fundamentally changed how you see your own incredible mind, please share it with a friend who always seems to be losing their keys. And I really want to hear from you. Drop a comment below telling me the one memory you wish you could erase, or perhaps the one memory you're absolutely terrified to lose. I genuinely read every single entry, and your stories, your questions, they truly fuel future episodes. Subscribe for more neuroscience that, I promise, aims to make your life simpler, not harder. Until next time, remember to keep forgetting the right things. It's how you thrive.